If you are new to the channel, then subscribe the channel and press the bell icon for further notification. Okay student, welcome you all to this new lecture in advanced level where you are solving previous year IIT JEE questions on differentiability. So in this lecture we will be solving from question number 9b to question number 12. Okay, then let's try to solve these questions. If mod of fx1 minus fx2 is less than x1 minus x2 whole square for all values of x1 x2, find the equation of tangent to the curve y equal to fx at the point 1. Let us try to find y, the function of y equal to fx. If I can find y equal to fx, what is this meaning of this something expression, then I can find the tangent, because tangent is nothing but differentiation, and you put the point. So what is given to you, this is given to you. So if you bring one x1 minus x2 one side, and if I think that x1 minus x2 is greater than 0 for time being, x1 minus x2 is greater than 0, if you bring it this side, you can do it in reverse way also, that doesn't make, because here it is mod only. So if it is x1 is greater than x2, so if you take this mod, I'm taking it, considering it is greater than 0, so you can put a mod, no issue, because it is positive only, so you can put mod. So this mod you can bring it this side. And how? Because why these inequalities are not changing, because I am considered x1 is greater than x2. Okay, so this mod I have taken outside. I have just taken a limit in both sides where x1 is going to x2. So what is the meaning of this one? You are at x1, you are going to x2, but it is very close, because you are just moving x1 to x2 and x1 minus, so you are moving from x1 to a point x2. Tending means it is very close, so very close, and upside it is fx1 minus fx2, this difference divided by x1 minus x2. What is the meaning of this one? This is nothing but differentiation of function at the point x1, because you are moving very small, just going to x2. So that's why f dash, it is nothing but f dash x1. So this is given, and this is, because if x1 moves to x2, then this is 0, this goes to 0, because this goes to 0, this is very close, the difference is very close there. So obviously then this side is less than 0. So now mod is less than 0. Mod is less than 0 never be possible, because mod is always positive. So it will be only possible if it is equal to. There is also equal to option, either less than or equal to. So it will be possible if it is equal to. So if f dash x1 is equal to 0, that means what is your original function fx? It should be some constant, because your differentiation is 0. So the original function something of this constant format. Then if you do differentiation, it will be 0. So that means your function is a something of constant function. So if your function is a constant function, constant means it is a straight line. Y equal to c means it is parallel to x-axis. So the tangent of this line at the point 1, 2 will be simply this line itself, because tangent of one line is only tangent. At any point, if you take tangent of this line, it will be tangent only. So that is equal to y equal to 2. And you think why it is constant? Because it is also they have given for all value of x1, x2. So that's why it should be something constant, so that it becomes 0. So you put any x1, it should not. Otherwise you may think of this fashion also. If you take differentiation of this one 2x, so you can say, sir, at x1 it is 0. You can see, sir, f dash x1, if you put it is 0. But it is for particular x1, one particular value. But it is for, you can write it either x minus 1 or x minus 2, x minus 3, any particular x1. But it is for all x1. So it should take some such function, so that differentiation becomes 0 every time. So that's why it is a constant. Now if you come to question number 10, again the mean of three functions. So you have to take draw three functions, y equal to 1, y equal to x square, y equal to x cube. So this is y equal to 1, this straight line, this is y equal to x square, this parabola, this is y equal to x cube. So you can see x cube will be below x square before 0 to 1, because 0 to 1 is a fraction. If you take more power, the fraction will get more reduced. So mean of this one. So here you can say mean is this one. When you come here, mean is this one. When you come here, mean is this one. So from here to here, it is the same curve, x cube. Here is a change. So it is, you can say there is a sharp turn in one. So it is not be differentiable. So they are asking f dash x is 0 every time. So let's check. The first one, fx is continuous. Okay, it is continuous. You have seen it is continuous. F dash is greater than 0 for all x. For x is greater than 1. So x is greater than 1. You come to here. Here f dash x is 0. So obviously B is not wrong, correct. C, fx is not differentiable but continuous at for all x. So fx is not differentiable but continuous for x equal to 1. I have missed is something. For x equal to 1. At x equal to 1. So at x equal to 1, you can say it is continuous but not differentiable. So C is also correct. And D is fx is not differentiable for two values. No, for two values, not for two values. It is not differentiable only at x equal to 1. So D is not correct. So if you come to question number 11, fx is given x minus 1 to the power n ln cos m x minus 1 for x lying between 0 to 2. M and n are integers, where m is not equal to 0, n is greater than 0. Let p be the left hand derivative of mod x minus 1 at x equal to 1. Then limit x tends to 1 plus g of x is given p. So let us find the left hand derivative of this one. That will give me p, then I can put it here. What is the left hand derivative of x minus 1? You can see this is your x minus 1, mod x minus 1. So what is left hand derivative? This. So this is actually minus 1, this slope is minus 1. You can see the slope of this line is minus 1. Or you can do the differentiation also. For less than 1 it is minus x plus 1. If you do differentiation, left hand derivative, that's why I am doing 1 minus, that means less than 1. So if you do differentiation it is minus 1. So p is minus 1. That means they have given this is equal to minus 1. And what is g? So if you write g of this fashion. Okay. Limit x tends to 1 plus. Now if you put 1, what will be the value? It will be 0. If you put 1, then it is ln cos 0 is 1, ln 0 1 is 0. So 0 by 0, that is undefined L'Hopital. So you apply L'Hopital rule directly. No need to think what should I put. Or here what I have done, I have tried to put log formula, but you can use it L'Hopital anytime, no issue. Directly you put, and the differentiation will not be so lengthy. You can do it, that is no issue. Or you do it like this way also. This is log, what is the formula? Log 1 plus x by x, limit x tends to 0 is equal to 1. Okay, so if we apply this formula here, limit, so it is, if I treat this is as a x, so 1 plus x minus 1, because I need 1 plus x, so I have given 1 plus x. This one is extra 1, that's why I have given minus 1. So this whole thing now is treated as a x. So if you think this is a x, this is x, this is x, this is x, and x should be tends to 0. That means this should tends to 0. If you put x equal to 1 plus, limit x equal to 1 plus, it was going. If you put 1, that is that is cos 0 minus 1, that is 1 minus 1 0. So you can say your cos x minus 1 limit tends to 0. So these things tends to 0. Therefore log 1 plus this by 1, these and this, all things should be same. So this is 0, this is 0, and also limit this is 0 going to 0. So obviously this will give me 1. So this is 1, this is n, this is cos, because I have divided by this one extra, divided by this x required, that's why I have divided it, and I have given 1 into also, that's why this is this. Now if you apply here, again say same problem will occur, again you can go with differentiation, but I have applied here 1 minus cos theta is 2 sin square theta by 2. So for this square theta by 2, why I have gone for n? Because here actually you need to find the value of n. So that's why L'Hopital rule will not give you n. So that's why better you go by the formula. So if you go by the formula, you can also try, no issue. But because I need to calculate n, that's why I have gone this way. So 1 minus cos theta is 2 sin square. So for sin square you need this square. This one I have given extra. So this one I will put it there. So this thing is 1, that is I am into minus 2, and this is this much. So this is this much. So ultimately you will get 2 by this. Now if your n is more than 2, if it is 3, then your answer will be, if you x minus 1, if you put x equal to 1, then it will be 0. If your n is less than 2, that is 1, then denominator there will be 0, it will be infinite. So because you need a finite value minus 1, so that's why your n should be 2, then only it is possible. If n is equal to 2, then this get cancelled, so 2 by m is equal to 1, then m is equal to 2. So this is your answer. Now if you come to question number 12, let f R2 R be a function such that fx plus y is equal to fx plus hy, and x for all x y belongs to R, fx is differentiable at x equal to 0, then fx is differentiable only at finite interval containing 0, fx is continuous, fx is constant, fx is differentiable except at finitely many points. Now if you come to this one, they are asking f dash x. Now if I want to take fx is differentiable or not, that's what I am checking. So if I check fx is differentiability or not, so before that I need to check continuity. But for continuity, one thing you know, fx is continuous if limit, so if your limit h tends to the f of x plus h is equal to f of x, that means if you increase little bit function, then also it is remaining same. That was the definition of limit. Okay, to check that one, here it is fx plus y, it is given fx plus sy. If limit y tends to 0, then this one is equal to this, limit y tends to 0, f of x plus f of y. So limit y tends to 0, f of x, limit y tends to 0, f of y means if you put 0, So it is f0. Now what is the value of f0? To know the value of f0, you try in this way. Fx plus y equal to fx plus sy. If you put 0, so 0 plus 0, 0, 0. So that means f0 is equal to 1, f0 will go, that means f0 equal to 0. So this one you know. So that's why I will put this one here. So you can see this is the definition of limit. Continuity. So if limit y tends to 0 f of x plus y is equal to f of x itself, then it is a continuous function. So option B is correct, it is continuous. So to check differentiability, this is the definition of differentiability, limit h tends to 0 f of x plus h this. Now what is f of x minus f of x? F of x plus y is equal to f of x plus f of y. So f of x plus y minus f of x is equal to f of y. So here f of x plus h you can write instead of y. So f of x plus f of h. So f of x plus h minus f of x is equal to f of h. So this entire thing will become f of h. Now I have introduced one 0 here, because 0 I can easily introduce. So 0 is nothing but f0 is 0 I know. So it is f of h minus f0 by h. So 0 I can write 0 plus h minus f0 by h, which is nothing but you are taking differentiation at x equal to 0. So it is f dash 0. But f dash 0 is defined. It is defined because they have given the function is differentiable at x equal to 0. Because it is defined, so obviously this will also define, and this is differentiation of fx at any point. So that's why it is also true. Because they have given it is differentiable at x equal to 0, it will have some defined value, so your f dash x is also defined. So option C is also correct. That means it is differentiable at all points. So B and C continuous, and C f dash is constant, because your differentiation is becoming constant. It is f dash 0, every time it is becoming f dash 0. So A and D are wrong. If you like the video, then press the like button and please give your valuable comments in the comment section.